Here's a video about parent sine and cosine graphs, which you need to know really well in order to do transformations of these graphs, dilating them, translating them, etc., which we'll do very soon. So here I've got a unit circle, and I've got the axes marked, or the coordinates of each point on the axes marked on this unit circle. And we're thinking about this angle theta traveling around this unit circle. So here's some position of theta. And what we're interested in graphing is what's the sine value right there, what's the sine value right there, what's the sine value in any particular place as we move this angle, as this terminal ray moves around, positive or negative, around the circle. So let's start here. At 0 degrees, the v value is the sine value, so that value is 0, so we can put a dot right here at the origin. So the sine of 0 degrees is 0. If we move up to 90 degrees here, then our v value is 1, so we could put a dot there. If we move to 180 degrees, our v value is 0, so the sine of 180 is 0. The sine of 270 is -1. The sine of 360, we're back to the same, something coterminal with 0, so we're at 0 again. If we go to 450, we're at coterminal with 90, so it's at 1 again. If we go in the other direction, if we had traveled around in a negative direction, if I can get this work, down here to -90 or -180, then our v values would again be the same as what they were at 270. -1 and 180 is the same as a +180, which is that. So there are a bunch of dots. I could have also filled in some places like at 30 degrees, the sine is 1/2. I just happen to know that. At 150 degrees, it's also 1/2. So I could fill in a lot more dots, but I'm not going to do that right now. But I am going to show you what the graph looks like when you do fill it all in, and that would be like this. Here is a sine graph. Here are some things to note about this graph. The maximum is 1. The minimum is -1. It goes through one complete cycle called a period. One fundamental period is 360 degrees. If you trace that, it goes up, it goes down, it goes back through the theta axis, it goes down to a minimum, and it gets back to where it started and starts to go up again with one full cycle at 360 degrees, one time around the circle. That's an important thing to remember. Max and mins are also important. Those are really important when we start dilating and translating these things. That's what the parent function of sine looks like. Let's take a look at the parent function of cosine. Same thing. We're going to move this angle around the unit circle, and starting at 0, now we're looking at the u value. The u value is 1 here, so we put a dot at 1, and then we go up to 90 degrees and the u value is 0, so we put a dot there. Then we're down at 180 degrees and we're at -1, put a dot there. 270, we're at 0 again. 360, we've gone one full cycle, we're at 1 again. 450, or coterminal with 90, we're at 0 again. If we go in the negative direction, at -90, we're at 0 again, and at -180, we're at -1 again. So these are the important points that we really want to pay attention to when we're doing any sine or cosine graph. Where it hits a maximum, where it's on the theta axis, where it is on a minimum, and so forth. So these, once we get those dots in here, we can just make a nice smooth graph and connect them all. We don't have to put in all the other points like I said before, 30 or 60 or 45. So that's what a cosine graph looks like. Notice that the sine graph went through the origin. Cosine graph, they look exactly the same. They're exactly the same shape. They are called sinusoids because they have this shape. Just like a parabola is called a parabola because it has a certain shape. This is a sinusoid because that's the shape of it. And the cosine starts at 1 on the y-axis, and the sine starts at the origin on the y-axis. That's it. Thanks for watching.